Welcome to yet another daily challenge of Leetcode. So today we'll be seeing last moment before all the ants fall out of a plank problem. So if I could maximize this, we can see it's a medium rated problem. Says that we have a wooden plank of length n units. Some ants are walking on the plank. Each ant moves with a speed of 1 unit per second. Some of the ants move to the left, the other move to the right. When two ants moving in two different directions meet at the same point, they change their directions and continue moving again. Assume changing direction does not take any addition time. When the ant reaches one end of a plank at that time t, it falls out of a plank immediately. Given an integer n and two integer arrays left and right, the position of ants moving to the left and the right return the moment when the last ants fall out of the plank. So it denotes the working model as well. 1 and 2 and B. So one solution is to go keep a track of each movement within an with respect to ant. So let's suppose what I'm saying is if you have four ants over here, take an array of four, indicate every position within the array. Have a second array with a direction. Uh, with respect to direction, you need to increment the position after each iteration, decrease the position post each iteration as per the direction goes on, and then you can go ahead and check whether two ants coincide or not, and if that does, change the directions, and you can go ahead upon doing the same. If they again does, change the directions as well. Keep moving until the counter until there is no ant left. That means the position within an array uh, becomes less than 0 or greater than the length of a plank. So, and you can keep the count of time and later return the time period as well. A very basic simple approach. This can be done. So it says that let's see about constraints. What does constraint say? 10 to power 4. It is pretty much okay solution for such kind of thing. As per our solution is very naive, we can implement directly with such kind of constraints. No such big deal. So it also say that left length is this, right length is this, obviously. All values of left and right are unique, and each value can appear only for one of a two array. Great. So this can be done. So could we go ahead and start to code? Uh, well, that might not be the proper solution until we see an appropriate way we could do this. Is let's iterate back to the problem statement. So we say that the ants change direction whenever they collide or uh, whenever they are at the same point. So in this case, B and C, let's consider and C both are the same at t is equal to 1 on the position 2. So B was traveling from right to sorry, B was traveling from towards the right. Now B has changed its position to the left. But does it matter to us? The only thing which matters to us is one ant changed its direction and the other as well. They were moving in opposite direction. They moved. They were moving east to west, west to east. They have moved east to west and west to east. Uh, that's the only case. So we can say that the ants, instead of colliding and changing their route, they passed through each other and they kept continuing. So I can say B and C. The B ant, one ant came from 3 to 2, 2 to 1, 1 to 0, and it fell off. Same goes with such an ant. So it makes sense for us to calculate the maximum distance which it requires to fall, be it from the left and be it from the right. Make sense? So as the speed of ant is 1 unit per second, which is mentioned here, so it makes sense for us to just say that the distance is directly equal to the time period. Sorry, speed is also equal to time period. That is the reason if we calculate the distance, we got within how much time would they fall. So in such case, 4 would take 1, 2, 3, 4 amount of time to fall, right? So goes with zeroth position ant, which is A, maximum of 4 and 4. That means maximum of A and D is same, which is equal to 4. So we are going ahead with an answer as 4. This is the simplest logic which we can say. So let's start with the code. As you have seen, that this is no more than a brain teaser that ants pass through themselves. This was the whole essence of a problem. And as ants travel 1 unit per second, then the entire time would be the distance itself. And we need to know what is the maximum distance for the last ant. So for considering ant D, which my pointer points to, the maximum time would be 4. 4. And for A, it would be 4 as well, but within the right direction, as and D would fall in the right direction, left one, left side of a table, and A would fall on the right side of a table. Let's verify this. It says 4, which is what we want. And in example 2, let's check it as well. 7 and 0. And the obvious option is it is the 7 distance away, so the time is 7, and which is also true. And here, this is as well true, but in the reverse direction. Anyways, time is not bound to direction as well. So let's start with the code. So we have two arrays, left and right, saying left ants moving to 0 and right ants moving to n. Make sense? Yep. So we say that now in such case we need to find the maximum. So we need to find the maximum time. So maximum time for the left array, left ant is to completely move to the uh, to the zeroth index, and hence the maximum time would be the farmost right point. And the farmost right point for the left one is for left one max is the farthest element. So for the left one, maximum time denotes the maximum number, and for the right one, maximum time denotes minimum number. Pretty much simple, isn't it? So let's say int position of farthest left ant It's a pretty huge name, I understand, but this is something which is making sense, and this certainly qualifies me as a Java developer. Arrays.stream. Those who do not know this name, Java developers are being criticized for using such long names, either it be for method or for a variable. So stream left, and I'm checking streaming the array from the left. I'm taking max, and it gives me an optional element I'm getting as int. Similarly, I will do it for the position of the farthest right ant, uh, but only this time I'll get the minimum one, right? So ultimately, I'll see what is the maximum time for to reach from the left and right comparing. So I'll say max from the position of farthest leftmost ant is, I'll just copy the name, that would be much more simpler, minus 0, comma, n minus the farthest ant from right, the rightmost farthest ant. Let's compile this and check this. It gave an error. So what does it say? It says no value present, no such element exception. So we get such exception because it is it's an exception saying if the stream is itself is empty. So we need to handle this case by saying uh, left equals to left dot length equals to 0. Then I'm returning the maximum as 0. Why 0? Because 0 is the most worst case maximum, as it's a minimum value. Same goes with here. Right dot length is equal to 0. Then it's 1. Sorry, it's n, because it's the minimum's worst case condition, as it is a maximum number. Let's compile this. Oopsie. Seems it took some other direction. Okay, I want to take this as right. That's the reason. And yep. So my sample test cases are passed. Let's submit this to check it for remaining test cases as well. So yeah, it says accepted. So this was about this problem. It was kind of more brain teaser than the solution oriented or the programming oriented. So such kind of problems do occur only within the introduction section or post introduction sections within an interview. But it's good to have a clear mind, and it's better to look upon the problem statement rather than diving straight into coding. So think twice, code once. Well said and highly implemented by this problem. So this was all about it. I'll see you in the next one. Till then, stay safe, keep coding. Bye.